Hey, let's jump into the review key for the first review. As I was talking in class yesterday, when you're doing substitution, you are going to want to look for the variable that is the easiest to get by itself. So both equations have an x and a y. And if you notice, if I solve for y in the second equation, it's going to be the easiest because when I subtract my 2y from both sides, I end up getting y all by itself with a positive 1 coefficient. It's going to be the easiest for me to handle because um, get y alone, I do not have to worry about dividing at the very end and causing everything to be a fraction. So I end up getting y is equal to negative 1/2 x plus 1. And I'm going to plug that into the other equation for y. And so I'm going to have x plus 4 times negative 1.5x plus 1 is equal to negative 0.5 plus 4x. And now I'm going to distribute, and I have x plus, I'm going to multiply 4 times 1.5. I get negative 6x. So let me change that. Plus 4 is equal to negative 0.5 plus 4x. Now I'm just going to combine all my like terms, and I get negative 5x plus 4. And then I'm going to subtract my 4x here. I get negative 9x. I'm going to subtract 4x on this side. Get negative 4.5. Divide by negative 9. And I know 4.5 is half of 9, so I get x is equal to 1/2. Remember, we always want to use fractions. It's okay that I use a decimal throughout, especially if it's it has to be like a perfect decimal, not like a 0.3 repeating. But in the end, I want it to be a fraction. Okay, my y by itself, I'm going to plug in 1/2. So I'm going to go back up to best part about substitution is the other variable that you're finding for is already isolated by itself. So I'm going to write y is equal to negative 1.5 times 1/2 plus 1. Just going to plug that all into my calculator. I get negative 1.5 times 0.5. I'm going to add 1, and I get, turn that back to a fraction, and I get 1/4. And then together, right, these are the inputs and outputs that work for both linear equations. So I want to write that as a solution point, which is, I'm about to write it backward, well, no, 1/2, comma, 1. Okay. Second one, if you were in class yesterday, we talked about, well, what I don't like about this equation is that it contains a bunch of fractions. So I'm just going to multiply by the least common denominator of both of these, which for the top is 6 and for the bottom it's 18. The only mistake that I see some students will want to multiply the 6 to the numerator and denominator. Just remember the number 6 is 6 over 1. If I multiply the top and bottom by 6, then I'm really multiplying by the number 1. I don't want to do. So the first thing I get is 6x divided by 2, which is 3x. Then I get negative 3y divided by 3. I mean, negative 6y divided by 3 is negative 2y. And then 6 times 0 is 0. Do the same thing with 18. 18 divided by 6 is 3x. 18 divided by 18 is negative 1. And then half of 18 is 9. What I'd probably do here is you could multiply the bottom by a negative 1, or you could subtract either. And so now I'm going to add these two equations down. My x's cancel. I get negative y is equal to negative 9 divided by negative 1. Y is 9. So I'm going to write 9. This is where substitution's a little bit better, is when you go back to plug it back in, you already have the variable that you want on the second one isolated, not with elimination. So I'm going to go pick one of the friendly equations. I'm going to pick the second one that I crossed out. So 3x minus, and then I'm going to plug in 9 is equal to 9. And then 3x is equal to 18. I'm going to add that 9 over, divide by 3, get x is equal to 6. So I have 6 comma 9 as my solution point. Okay, so same as delta math. The only one that might be a little bit different than these two is just decimal, and you might need to cancel off a denominator. Everything that's within our wheelhouse. Same thing with this elimination. It's if we take a look at this one, I kind of line up my variables on top of each other, and then I'm going to look at their coefficients and see which one is the easiest to multiply by something to cancel out the other one. And sometimes you have to multiply both equations by something. And I noticed that, okay, for me to get a 2, this fraction has to be multiplied by something to get 2. And I know this would have to be 10, because 10 divided by 5 is 2. And I don't know anything that multiplies by 3 to get 10. So that one doesn't look as easy. So I'm going to move on to this y1. And I'm going to look, something times 0.2 is equal to 3. And I said, that seems a little bit more reasonable. And you could always set up an equation, right? I want to know something that multiplies by 0.2 that equals 3. That's the same as taking 3 and dividing it by 0.2, and I get 15. So I'm going to multiply this denominator by 15. It's already got opposite signs for the two y's, so I'm good there. And I really like that the 15 is going to cancel with the 5 on the first term of the x. So I get 15 divided by 5, right, is going to be 3, and I already had a 3 up here, so that's 9x. And then I know 15 times 0.2 is going to be negative 3y. And then I've got to do negative 3.6 times 15. And I get negative 54. Okay, and then I've got to kind of just like mentally cross this out. And I'm going to combine my next two. So I have 2x plus 9x is 11x. My y's canceled. I did that. Equals negative 55. This makes me feel really good because I have a nice whole number or integer when I'm done. Just because it's a fraction or decimal doesn't mean it's wrong, but when it comes out like that, it makes you feel like you did the answer right. So I'm going to plug this up to the first one. So 2 times negative 5 plus 3y is 1, negative 10. I'm going to add my 10 over, and I'm going to get 9. Y is equal to 3. So together they make the solution. If I input negative 5, both of these equations will output 3. And graphically they would intersect at negative 5, 3. I was also saying before, notice that there are 3 different problems here and 3 sets of direction. One said by substitution. So if you have a test, I need to see your work in substitution, not elimination, or in your graphing calculator. Number 2 says solve the system. Didn't ask how to do it, but obviously I want you to do it by hand. And so elimination is what we chose. I didn't have a specific request. And on the third one, it did ask for elimination. Okay, and the next one says graphing. So we talked about y equals mx plus b. So I'm going to subtract this 5x. I get 4y is equal to negative 5x plus 2. I'm going to divide by 4. Y is equal to negative 5/4. And that one's not that fun because it's got that half, but we can handle it. I'm sure it says solve by graphing and they give us a hand graph that it's going to come out okay. So my next one is I'm going to add my 5x to the other side. Negative 2y is equal to 5x plus 4. I'm going to divide it by negative 2. Y is equal to negative 5 halves minus 2. I left this off on both of those. Okay, and now I'm ready to graph. I'm going to start with the first one, and I'm going to start off at a half, which is right here. And I'm going to go down 5 and right 4. So down 1, 2, 3, 4, 5, 1, 2, 4. And then I'm going to go up 1, 2, 3, 4, 5, and left 2, 3, 4. Okay. Before I put any lines through stuff, I'm just going to graph my other point. And this one is at -2. And I'm going to go also a negative slope. I'm going to go down 5. I don't know if I can if this will go all the way down 5. Let's look 1, 2, 3, 4, 5. But I can do my best. And then over 2. And then up 5. 1, oops. 1, 2, 3, 1, 2, 3, 4, 5, 1, 2. And now I'm going to put my line in, doing the best I can to make this a straight line. And I'm going to do the same thing with my, oops. Definitely looks like it intersects at this one nice perfect point, which is -2, 3. And if it was me and this was on a test, I would leave it as -2, 3 and continue with my test. But then at the end, if I had time to check my answers, I would go back, plug these two in my calculator, and use my intersection just to verify that that is correct. Okay, my next one is my graph of my quadratic and my linear. So I'm going to solve this algebraically. I'm going to solve for y and plug it in. I'm just going to work this quadratic. X squared minus 2x plus 1 minus 4. Now I'm just going to get everything over to one side. So I'm going to add this x, add this 1, combine like terms. So I have x squared minus x. This is plus 2 minus 4, which is -2 equals 0. And I get x minus 2, 1. So x is equal to 2 and x is equal to 1. And these are not x-intercepts, right? Well, could be, but these are the solutions. So I've got to find my y. Well, I use substitution. So I should have an equation ready to answer with my x value. So I have y is equal to -2 minus 1. So 2, -3. And then I'm going to plug the x of -1 in. So negative and a negative make a positive 1 minus 1 is 0. So when x is 1, my y is equal to 0. I'm going to move over here, do a quick sketch. So I'm going to graph my quadratic. And I know this was what, 1, 2, 3, 4. And I know if I go right 1, that distance, square it. I go 1, right 2, and then up 4. And that would be an x-intercept. So left 1, up 1, and then over 2, up. Should look something like this. And then I'm just going to graph my intersection points. 2 points is enough for a linear line, and I have one at -1, 0. And I also have my other one at 2, -3. And there's my rough sketch of my quadratic. Those are really good just to do by hand without looking at your graphing calculator. Really build your skills in graphing when it comes to the 10 ready. Okay, number 6. I'm going to do the same thing. So I'm going to isolate my y by myself on my linear. That's usually the easiest way to do it. And I get x squared plus 2x minus 5 is equal to 3, 5, 7. And x squared minus x is 2. It's after I minus 3x. I'll get my negative x, add my 7, that's 2. and I'm going to solve this quadratic. Did notice on the log ones there were enough students to where they did do the loop method and they got a quadratic trinomial, and then they try to do weird things besides factoring to solve. Remember, when I have a quadratic, I must always think about factoring. Okay, so I think numbers that multiply to get 2, that don't add, that add up to get -1, they don't exist in E. That's the quadratic formula. So opposite B, plus or minus the square root. I'll come back to that. And then 2 times my A. Remember, this is A, B, C. And then my discriminant, the number underneath the square root, I always love to do over to the side. That is B squared minus 4 times A times C. I get 1 minus 8, which is 7. Plug that under there. And I know because I get a -7, this is no solution. That's all I have to show, Mr. Pavanich. So what that means is no intersection. So what this means is there are no inputs that I can plug in for both equations, like a one single x that I can plug, or two that I could plug into the equation and get the same output. So now I just need to graphically show that. So I'm going to graph 3x minus 7. Let's call this -7 and go up 3, 1, 2, right 1. That's probably pretty good. Just a rough sketch. And how could I find the vertex of this quadratic? Well, let's look. We did opposite b over 2a. Remember that is our x value of our vertex. Well, here's opposite b over 2a right there in our quadratic. So that's 1/2. And let's see. Very interesting. Oh, I did opposite b over 2a from the, I'm not thinking from the two set equal to each other. So I'll have to do opposite b over 2 times my a, which 2 times a is 2 here. Sorry about that. It's -1. And if I plug a -1 back in here, I get 1, -2, and -5. So I get negative, so I get -6, -1, -6. I know these don't intersect. And there's a rough sketch of my graph. Okay. So excuse me on the detail. This would have been okay if it was the original. But remember, I said it's equal to 0. It's not the same equation. So this opposite b divided by 2 is different from obviously the original one. Okay, next one is, I don't know why we went to number 4, but here we go. It's a number 4, and with these word problems, you just got to remember, hey, what am I doing here? I've been solving two equations with the same two unknowns, so I'm probably going to have to create two equations with the same unknowns. So a carpenter is building a square room with a square adjacent foyer, including according to the floor plan. If the total area, so we know area, so, and the perimeter, so here's probably the second one. Okay, and that is 256. Find the lengths of the sides of the two rooms. Okay, so the total area and the total perimeter. So area is of this square, right? Would be of x's, would be x squared. And then of this other square, which is y, is y squared. And that's going to equal 3, 2, 8, 4. Looks like a circle. Equation. Oh no. Second one's perimeter. Perimeter is adding up all the sides. So I have 256 is equal to, let's look, x plus x. So I have 4x. And I have 3 y's. Why don't I have 4? Because I counted this as my x, right? It's the fourth side, so I'm already accounting for that, so I don't want to account the y because it's already part of the x, okay? But this is the important part. If this is a room, we're going to assume that this room is open here. So I'm going to have to subtract my y off, and that will leave, since I called this whole side x, right? If I take just y away, then that just takes away that wall. I'm assuming that wall doesn't exist between those two rooms. Okay, so it's 256 equals 4x plus 2y. Okay, now I have my two equations. So what am I going to do? I'm going to solve for one of my equations. I'm going to solve for y. And when I get y by itself, I'm going to get 128 minus 2x. That's by subtracting my 4x and dividing everything by 2. Okay, and now I'm going to come over here to my equation, and I'm going to substitute that in for my y. So I have x squared plus 128 minus 2x squared equals 3284, and x squared plus, this is a difference of squares. I mean, not a difference of squares, a perfect square, right? So you're going to multiply 128 times 128, and I'm going to get 16,384. And then I'm going to multiply my 2x times my 128, and that's going to double up. I'll have negative 512x. And then I have plus 4x squared, and that's going to equal to 3284. Okay. So the next thing I'm going to do is combine my like terms. So I have 5x squared minus 512x plus 13,100. Moving this over. Okay, and then I'm going to factor. And I know that this has got to be a 5x and an x. And now I've got to find my factors that multiply to get 13,100, which is negative 50. I know it's got to have a 0 on it, right? And negative 262. Not the easiest numbers to find out. So when I solve this one, I get x is equal to 50. And when I plug it in, I get 28. And this one, I get this one right here. I guess I did that backward. Let me change that. This one is x equals 50 and y equals 23 or 28. And then my second one is x equals 262 divided by 5. And y is equal to 23.2. Okay, so my next problem is I'm going to look at solving and graphing a solution on a number line. Again, what I don't like about this problem on number 8 is the fraction, so I'm going to multiply both sides by 4. The 4 cancels out the 4 on this side, that leaves the 5. The 4 reduces with the 2 and gives me a 2, but that 2's got to distribute through, so I get 6 minus x. And now I'm ready to solve. Remember, when you divide by a negative with an inequality, you got to flip that sign. Number put it on a number line, and This is 0, this is, and it is greater and open. Remember on these double inequalities, what I do to one side, I have to do to the other. I got two sides. 5 by 4, divide everything by 4. It's not negative, so everything stays. And these should look like an and statement, which looks like a bell, like a weight set. And the next one is an absolute value. This is one that you split up. You have your positive side of 0, and then you have your negative distance. And now I'm ready to solve. 1 and x is less than 1. And then my other side, I'm going to add 1, divide by -2, define inequality, and then I'm going to graph this. I have 1 and I have 2, both are solid. X is less than 1 and x is greater than -2. So it's an and statement too. Okay, my next one is solving a system of inequalities graphically. So I'm going to go ahead and do that. I just wanted you to sketch these just to kind of get the hang of sketching and remembering that my vertex here is 1, -1. And I'm going to go over 1, and 1 distance is squared is 1, but then I have an a of 2. So it's going to actually go up to 2. And then if I go 2 away, 2 squared is 4, but I have an a of 2, so it goes up 8. So 1, 2, 3, 4, 5, 6, 7, and just a little 1 up. Okay. And then I have an axis of symmetry, so I know if that one's 1 away, it's 1 away. And this one, if it's 2 away, this one's 2 away. Okay. And then my next one is -2, -1, or +1. And if I go 1 away and I square it, I get 1 times -2 is down 2. And 2 away is -8. So 1, 2, 3, 4, 5, 6, 7, 8. And then the same thing over here. 1 squared is 1 times 2 is -2 is -2. 2 away, and then I get -8. And I forgot to dot both of these lines for the other parabola. Oop, oop, there you go. And technically, if we wanted to know which one's less than, this would be what we shaded. But we didn't go over that, so nothing much to worry about. Okay, next one is I have a system of linear and circle. And so what I want to do is I want to be able to graph both of those. So let's just do the circle. That's a pretty easy one. It's got a center of 0, 0 and a radius of 5. And I have a line y is equal to -x plus 5. So let's go to 5. There's one of the intersections. Down 1, right 1. Down 1, right 1. And those look like they're going to be both nice intercepts. 0, 5, 0. Okay, but it did say to solve these both algebraically. So let's go ahead and do that. I'm going to plug in my y value. So this is x squared plus, and then I had -5 squared equals to 25. And so I have x squared equal to x squared plus x squared minus 10x plus 5. equals 25. And so I get 2x squared minus 10x equals 0. And then here I'm just going to pull out a 2x and make x minus 5. And then I'll just have to set those equals. So I have 2x equals 0 and I have x minus 5 equals 0. So I get x equals 0, 5. And when you plug this back in, you get 0, 5. Okay, our next one is a little bumped up a little bit. It is our ellipse and hyperbola. So what I'm gonna, or parabola. So remember, for a parabola, you're gonna solve for the variable that's not squared. So I have -3 y squared equals 9. Divide everything by -3. Sorry, that should be plus. So x is equal to -1/3 y squared minus 3. And so what is this? This is a vertex of -3 is the x, and there's nothing in with the y squared, so it's 0. I have a -3, 0. And then I have an ellipse. So this one is opening to what? It's negative, right? Did I do that right? Oh, I forgot to subtract it over here. So it'd be a positive. So it's going to open to the right. So we could do up 1, 1 away, 1 squared is 1. So I'll go times a third is a third. And then I could go 2 away, 2 squared is 4, times a third is 1 and a third. And then I could go 3 squared is 9, right? And then 9 times a third is 3. And same thing on both sides. So if I want to get a better picture of that. It's pretty close though. Okay, and now I want to graph the hyperbola, which is always equal to 1. I mean ellipse, early in the morning. And so I get x squared divided by 25 plus y squared by 9 is equal. So I have a center at 0, 0. And the x distance, remember, I'm going to travel the square of that denominator. So 25 is under x squared, so I'm going to go right 5, left 5. And then I'm going to go up 3 and down 3 because square root of 9 is 3. And that'll land perfectly on those. And so my solution looks like 0, 3, and 0, negative. And I'm going to trust that you'd be able to do that algebraically. Because we've already done 2 of those. So you would just plug in what did we solve for, x? Yep. And you would plug your x in up for probably, I would just write 9 times 1/3 plus 3 squared plus 25 squared equal to 225. And everything should come out pretty nicely since it comes out to 2. Okay, so my next one is my packages. So it says the Postal Service defines girth of a package to be the sum of its length. its height, and 3 times its width. There's one. It says the maximum girth UPS will accept is 130 inches. If the length of the package is 36 inches, so I'm just writing down what inequality describes the acceptable height and width for a package. Draw a graph showing the height and the width. Okay, so let's take a look. So I know that my length is 36. So here we go, 36 plus twice the height, 2 times the width. Has to be less than or equal to 130. Okay, that's the information they've given me. So now I'm going to subtract my 36 over, and I get 2h plus 2w is less than 94. Divide everything by 2h plus w less than 47. And that would be my package. I'm not going to graph that one, and I'm okay if we don't on this one. Okay, just being able to write that equation by reading the words. Okay, the next one is find two complex numbers whose sum, we worked this in class a little bit, is 6 and whose product is 10. Okay, now I'm going to do a little substitution, and I'm going to solve for A. So that would be 6 minus. I'm going to come over to A, do 6 minus B times B is equal to 10. And I get 6B minus B squared equals 10. And then how about negative B squared? Well, I think I want my B squared to be positive, so I'm going to move these two terms over. We get a B squared minus 6B and 0. Since I know I've got a quadratic, and now I'm going to try to solve that. Numbers that multiply to get 10 that equal negative 6. There aren't any. And it did say complex, so here we go. Quadratic formula. Opposite B is minus square root. Come back to that later. 2 times my A is 2, my A is 1, my B is negative 6, my C is 10. And then I'm going to do B squared for C. I get 36, 44. Square root of negative 4 is 2i. Divided by 2. And so what should my two numbers be? It's I and 3. I hope this video helped you. And if you have any questions, just text me on Remind.